Hi, Don Wedding here with DKW Analytics. And in this video, we are going to now explore the use of Python to do segmentation. And in this video, I'm going to just start off real basic. If you are a Python expert, you might notice that there might be better ways or more efficient ways to do the things that I'm doing. However, not everybody is a Python expert. So I'm going to try to keep things as vanilla and straightforward as possible so that people can take the techniques that I'm showing here and apply it to their own data. All of the code and the data that I have here, I'm going to provide links to this so you don't have to worry about copying it down. I will provide access to all of this. So let's take a look here. So before we get started, if you like this video and you find it useful, please hit the like and subscribe button. And also you can reach me at DKW Analytics. So let's get started here. Okay, so what I'm going to do is I'm going to start off by showing you the data set with which we're going to work with. So this is an insurance data set. And again, I will provide links to this as well. And you can see here that, let me open this up a bit. So what I have is data from, I believe, a fictitious insurance company here. And this is the first flag here is whether or not the person filed a claim after they got an insurance policy. So this is all of the data here, what they looked like when they got their insurance policy. And over here is, did they crash their car within the next 3 years? And if so, what did it cost us? So, for example, this person here, the variables that we use are things that they might ask you when you file an insurance policy. For example, do your kids drive? How many of your children will drive the car? How old are you? Do you have kids at home? Years on job? What's your income? Are you a single parent? Home value? Marital status? Are you male or female? What's your educational level? What is your job? Travel time to work? Do you use your car for private or commercial use? Blue book value of your car? Time in force of your insurance policy? Number of people on it? Car type? Do you have a red car or not? How many times did you crash your car? Or how much money did we spend to fix your car in the last 3 years? How many times did you crash your car in the last 3 years? Have you ever gotten your license revoked for drunk driving, traffic tickets, car age, and also are you driving in the city or in the country? So these are variables that are information that they would ask you when you go and get auto insurance. And over here is whether or not you ultimately crashed your car and what did it cost us. So we're not going to build a predictive model for this application. What we're going to do is we are going to simply do some segmentation. Take a look at the data and see if there's any segments here that will, for example, male versus female. Do they behave differently? Is there anything different with the data? Maybe your educational level, your job. We're going to look at this. We're going to segment the data based upon these categorical variables and see what happens. So let's start writing the Python code here. So I have some code already started. And what we're going to do is let's start off by, for this purpose, we are going to, let me say I should close this guy down so Python can read it. We're going to just start off, but for everything we're going to need here, we're just going to simply use pandas. So I'm going to, and maybe NumPy, I'm not sure. So let's just import pandas and NumPy. So that's what we're going to start off with, is these two guys right here. And also, let's just start off by reading in the file itself. So what I like to do is I like to create a variable called path, which has the path or the directory where my data is, and then the file itself. And this allows me to, in the future, if I move the file or if I move the location, I can simply change it in one place, or maybe the file gets updated, I can do that. So combining these two guys together is going to be in file. So that's what I'm going to do. I'll just run this real fast for you to show you what I have. And again, some people might be more interested in using a tool like Jupyter Notebook or something. I'm just using vanilla Python and vanilla, the editor that comes with Python idle. So anyway, so I type in path. You can see that it's going to be this is the path to where it's located on this hard drive. The file I'm going to use is that guy, and in file is everything combined. So I'm going to read this guy right here, and let's read him in. So okay, so this is the pandas command for that. Read this data file. I usually recommend using this as there's several encodings that you might want to use in case there's special characters. Sometimes you get an error. This one seems to be a nice one, a good catch-all there. So that's what that is. So I'm going to read this file, and if there's any weird or special characters, this encoding will take care of that. So let's read that guy in. And if I were to do DataFrame here, you can see this is the, I've read this data in to the DataFrame right here. DF is what I've read it into. And if I were to type in head, this will give me the first 6 or 5 records. I think first 5 records. And there we go. Now you'll notice that we have this obnoxious dots here. So what is that all about? Well, that's because Python is going to say, hey, listen, we can't fit all of that information on the screen. So what I'm going to do is I'm going to come down here and I'm going to set the size of my screen. So this is what I'm doing here. So I'm going to kind of walk you through what I'm doing for the people who are new to Python. I'm going to kind of walk you through some of the techniques that I use. So in this case, I'm going to say the display, the maximum rows, columns, width, etc. So I'm going to set this, and this should make it so that I can fit everything on the screen, hopefully. Let's take a look. Okay, so it all fits on the screen, but of course it's wrapping around. We don't want that. So let's try another technique. So I'm going to try you one other thing before we move into actual segmentation. So one of the things that I like to do is if I'm going to do print a data frame and use head or tail will give me the last 5 records. So if I were to do this and it doesn't fit on the screen, sometimes I will transpose it. Whoops, dot T for transpose. So watch this. And so now what I've done is I've transposed the rows and the columns. So now I've got the first 5 records. And now this is my variable here. This is the target flag. So the first record, record number 0, the person did not crash their car. So if they didn't crash their car, there were no damages. And you can see this person was 51 years old, et cetera, et cetera. They were female. They were married. They had a bachelor's degree. They're a manager. This is what this person is. Now, interestingly enough, we're also, and later on in our lectures, we're going to fix this, but you can see that in some cases we have missing values. Like over here, we have income for this person right here, person number 3. It says not unnumber, NaN. Okay, we're going to have to fix that when we do clustering. Right now we're doing segmentation. That we don't have to worry, but right now clustering, we're going to have to fix that. So okay, let's move along here. So we've read this guy in. I'm going to comment this out so we don't keep printing this thing out. It can be a little bit obnoxious. So now the next thing that I like to do is begin to explore the data itself. So let's do that real fast. And this is the techniques I'm applying here are things that I would do normally if I were to be exploring this data. Now, I'm going to look at this by group. Now, if you saw, let me go back one more time, and let's just take a look at some of the groups. When I say group, I'm going to talk segment. I probably should have named that thing segment. But let's see what kind of segments we have here. So I have things like sex, male and female, marital status, yes and no, okay? So these are, when we talk about segmentation, these are things that I can observe that are making, that make data different. So for animals, for example, you might have furry animals versus scaly animals versus feathery animals, animals that eat meat, animals that eat plant. We're going to look at the same thing. The data that we have here is customers. So we've got these customers, and the customers can be married and single, and they can be, using their car for commercial use or private use, and their job and things like that. So we're going to look at this, and we're going to segment based upon these categorical variables. So let's start off by looking at, I don't know, how about the person's job? So we're going to look at the job, and I'm going to create a variable called group right here. And we'll put this up here at the top. Now, the nice thing that I'm going to do is group is going to equal job. Now, if we go back here real fast, you can see I have a variable called job right there. So I'm just going to put job, but any variable, car use, whatever I want. Okay, so we're going to do this by job. So the first thing I will do when I want to look for segmentation is I want to see how many there are, how many different jobs there are. So if I just print df group, this is going to be the data frame, and it's going to say job. I could put job in there if I want. In fact, that's what I'm going to do. Well, let's read this guy in first. Okay, so if I were to say df job, oh, it doesn't all fit on the screen. Well, this will have all of the jobs only. So this would give me a list of everybody and what their job was. It would be a big long, group of those. So what I want to do here is ask how many different jobs are there. So let's go over here, and if I do unique, let me comment this out, unique, it's going to say, here are all of the unique jobs that we have. So we have manager, clerical. Let me take this. Probably is not all fitting on the screen, so let's move down here a bit. So I can say, when I do the unique, it's going to say there's managers, clerical workers, students, blue-collar workers, professionals, lawyers, doctors, homemakers, and NAN. Some of the people it's missing. We don't know what their job is. We'll fix that shortly, but let's just start off with this. We might want to look at value counts. Exactly how many are there? So let's run this guy here. This is the number of jobs, or the types of the jobs, and then let's look at their value counts. So now let's move this up a bit. And you can see that blue collar right there, I've got 2,288. So I've got 2,288 people who are blue collar. I've got clerical workers, 1,500 of those. Doctors, I've got 321. So this is the makeup of these people. So unique, this tells me what they are. This tells me how many there are. I can also see if there's any missing ones. So let's see how many are missing. So by doing that, I'm going to print the missing values. I'm just going to write in the word missing values here so we know what we're printing. We're going to say DataFrame group. Group is job up here. We're going to say, and then I'm going to put this dot is NA. So is this missing? And then I'm going to put dot sum, and this thing is going to add them all up. So let's run that real fast. And you can see I have 665 of these guys are missing. Just for fun, let's go back here. And the nice thing about putting this variable right there as group is that it allows me to change this to something else. Like, for example, let's look at marital status. I believe the variable was called marital status. If I run this now, it's going to give me the makeup. We have marital status, yes and no. We have 6,000 people are married, 4,000 people are not married, and none of those variables are missing. So there you go. So you can see that. So this is going to allow us to do this analysis. Just change this variable name. Okay, so now at this point we know that we have some missing variables and we know what everything is. I'm going to comment these guys out, and now I'm going to do something like this. I'm going to fix that missing variable. Now, how do we do that? Well, what I'm going to do is I'm going to come over here, and we now know that we have some missing variables, and I am going to say the data frame group, in this case it's job, and I'm going to fill my missing guys, fill NA, with the word unknown. And then by putting in place true, it's just going to shove it right there into my data frame. I don't have to create a new variable or anything like that. It's just going to fill it in, right there into the data frame. And then, for fun, let's copy these guys here and put them down here. And now we're going to print what are the unique variables, how many are there, and how many of them are missing. So let's run this guy now. So this guy is going to fix all of the missing variables. So let's take a look. Let me move this up a little bit. Okay, so now we got our blue collar workers, we got our clerical workers, professional managers, lawyers, student homemakers. Oh, look at this, unknown. Look, we got 665 of them. We got our doctors there, and look, nobody's missing. Great, they're all filled in. And look, even this, here's all of my different categories. Okay, so now we're ready to go. So what I want to do is I like to, when I start segmenting and profiling the segments. Now, the nice thing about segments is that they are obvious. I mean, you don't have to you're not clustering and grouping things together based upon, some kind of continuous variable. We're looking at a very discrete, obvious difference. You are either, married or you're not. You can't be a little bit married. No, you are married or you are not. You are male or you are female. You are left-handed, right-handed, or ambidextrous. These are very obvious things. So that's what segmentation is. So let's go over here, and when I'm doing my segmentation, what I like to do is I like to compare a segment to the entire population. So first of all, I'm going to have to get what is the average of all of my variables. So I'm going to create a variable here called M, capital M. Okay, and I'm going to say, hey, Python, this is a panda command here, panda, and well, if I just do df.mean, let's do that real fast. whoops, print df.mean. This is going to calculate the mean of all of the continuous or the numeric values in our data set. And so there, Python is obliging enough to say, okay, for everybody, the average age is 44.8. The average year on job is 10 years. The average time in force, how many years have they been a customer? 5. So this is the average of everybody, the entire population. Now, if I were to do something like this, if I were to say, let's do this guy real fast. Let's save that in a variable called m. So that's what we're going to do there. So we're going to say save all of those guys into m. So if I type in m, there it is. See, I've got them all. I've got all those averages stored there. But let's see what kind of type that is. Type of m. You can see that that's being stored as a Panda series. Now I'm going to want this thing to be a data frame. I could probably use it as a Panda series for my intents or my purposes, but I'm going to try to keep things as vanilla and straightforward as possible. I don't like to go and I'm going to try to keep this real simple. So I'm going to do things a little bit less efficient, but they're going to be a lot more understandable for people who are new to Python. So what I want to do is I'm going to force this thing to be a data frame. So pd.data frame, open parentheses. And so Python is going to now shove this into a data frame, and it should be a data frame. M should be a data frame when I'm done. So if I type M, you can see it's a data frame now. It's no longer a series. So if I type M, there it is. So this is my my data frame. However, the problem that I'm running into is each of these, I want this thing to be transposed. I don't want this to be a data frame with one column. I want it to have one row and many columns, each of these being a row. So, or sorry, each of these rows, I want them to be a column. So what I'm going to do is if I do m.t, I'm going to transpose it, and now everything is, I've got one row of data and I've got lots of columns. That's going to come in handy for me in a little bit. So let's do that right now. And I'm going to simply take this guy, and after I create it and make it a data frame, I'm going to transpose him. Now I'm going to print him. And it's not going to look as pretty when I print this, but that's not the point. I want it to be one row. Okay, there you go. So here's my single row of data, and you can see this guy is, the entire population has years on job of 10.4. Their home value is worth 154,000. You get it. So that's what this is going to look like. Okay, so now let's go back to our, we don't want to print this anymore. Are we printing anything else? I don't think so. Okay, oh, we don't need to print the mean anymore. Okay, so now I want to group the data. So now that I've got my average of everybody, now I want to get the averages of these guys by group. Okay, so what I'm going to do is I'm going to create the data frame, and I'm going to say, okay, data frame, I want you to group all of the data by, in this case, job. And it's going to store it into this little letter G. And then I'm going to calculate the mean of all of the variables, and I'm going to store it into little letter m. This is just a convention that I follow. The entire population, I'm going to use capital M, and each individual group, I'm going to use small m. That's my convention. You can do whatever you want. And then let's print those guys off. So now, let's run these guys. So look at that. That's, again, it's not really the most easy to read. Let's just print the little letter m with a transpose. Whoops. There we go. That's a little bit better. So now I'm going to transpose it just to make it more readable. And I'm going to say, okay, here's your job. You're a blue-collar worker. You have a 35% chance of crashing your car. You've got if we do crash your car, it's going to be $5,900. Your kids, 20% of you have 0.2 children driving your car. You're 43 years old. This is what a blue-collar worker looks like. This is what a doctor looks like. So this is the average broken down by a category. Okay, so let's see what else we can do here. Now the rubber is going to hit the proverbial road here, because this is going to be really cool. So let's do this. Now I'm going to start off by showing you how we're going to loop through this data one record at a time. Now again, there are more efficient ways to do everything I'm doing. I'm going to go again with the most direct way to do this for people who are new to Python. This will be very easy to understand, especially if you are coming from another language. So okay, so what I'm going to do is I'm going to say right here, for I in, if I say shape 0, let's go back real fast. Let me just go real quick. I want to show you what shape does. And if I do m.shape, then you can see that when I do that, Python is going to give me back a tuple. Think it's kind of like a list. It's going to say, hey, there are 9 rows and there are 16 columns. Okay, so if I type in M, I've got 9 rows because I have 9 jobs, and I've got 16 columns because I've got 16 variables. So I don't really care about the 16 columns. What I care about is these 9 rows. So all I need to do for Python is if I say m.shape and I put it like 0, this is just going to give me the number 9 because there are 9 rows. So if I were to do m.shape 1, there's going to be 16 because the 0th index was 9 and the first index was 16. So let's go back up here and see that. See 9 and 16. So 0 is this guy and 1 is this guy. So there we have it. So let's go back to, we're going to loop through for I, and the I is going to come back in the range of 0 to 9. It's going to stop at 9, so it's going to go 0 through 8. And then we're also going to need the variables. So what I could do here is I'm going to, let's grab the variables themselves. So if I do var, whoops, vars is going to equal m, whoops, m dot columns. And let's print vars. Okay, so let's run this guy one more time. And you can see that I've got, this is going to give me a list of all the columns here. Target, flag, target amount. These are all of the columns that are in M. Remember, M has my averages in it. M, whoops, that's not easy to read. M dot transpose. Look at that, much easier to read. So I've got, these are all of my jobs, and these are the variables here. Okay, so now I've got all of these variables are stored in a variable called vars. Look at that, right there. So now we've got everything we need. So this guy is going to loop where I is going to equal 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And over here for v in vars, and we can print them. Let's print I, comma, v. This is going to print every row and every column. Look at that. Okay, so you can see here, I've got the 0th row, this variable, the 0th row, this variable, blah, blah, blah. The first row, this variable, the first row, this variable. So I'm going to loop through all of those guys. Okay, now here's something that when you deal with Panda data frames, it sometimes is a little tricky to know how to index the records. In fact, if I just do this, let me just get rid of that guy. If I were to do print m dot iloc I, this guy is going to give me an entire row from M. So he's going to say, okay, we want you to give us, this is an integer location, so we're going to just say, give me the 0th row, give me the first row, give me the second row. Let's print those guys off and I'll show you. So there, he's printing them off one at a time. So this is the 0th row here, and this is the first row. That's what we're getting here. So what we want to do is break this down row by row. So now that we know that this guy is going to give us the row, then if I do at v, this is going to give me the first row, or the 0th row, and the first variable. The first variable would be, did they crash their car? Then the second row, how much did it cost? The third row, the third column would be, how old is the person? So I could do this real fast. So print I, comma, v, comma, this guy. Let's do that. So there you go. I can say the 0th guy, claim, and this person has got a 35% chance of crashing his car. It costs this much, etc. So I can now break this thing down very easily by, I can just pull out one element out of this, out of M. Okay, so now what am I going to do with this? Well, let's do this. We're going to say that this guy is going to equal to this, and we're going to divide it by the average of everybody. So what's the average of everybody? Well, remember capital M way up here? Remember that guy? We have one row, lots of columns, okay? So what we're going to say is we're going to take this guy and we're going to say the 0th row. We only got one row, and it's row 0. And so we're going to say I'm going to take whatever the age of the doctor is and divide that guy by the age of everybody. I'm going to take the age of the blue collar divided by everybody. So this is going to give me what is your age divided by everybody. What is your income divided by everybody? This is going to let me know how everybody, how a segment or a group is compares to the entire population. So let's do this real fast. So let's do print M. And we're almost done. Okay, so let's do m.transpose. So now you can see that my blue collar worker, I've got a number of 1.3. Well, what does that mean? It means that this guy right here, blue collar, is 1.3 times as likely to crash his car as is everybody else. A doctor is 0.4. So in other words, a doctor is much less likely to crash their car than the entire population. What about a, homemaker? So this would be a stay-at-home mom or a stay-at-home dad. And this person has a chance of crashing their car about equal to the entire population. So they're no different. So you can just see that there's some jobs that are very risky, some not so much. We can look at other things like income. So you can see a blue collar worker has got about 95% of the income of the overall population. What about a doctor? A doctor has an income of twice the average of everybody. A lawyer 1.4 times, a manager 1.4 times, and professional like an engineer 1.2. So this is kind of how that works. Now, personally, this is a little hard to read because these numbers are, lots of decimal places. So what I like to do is I will round that. So round M to 2 decimal places, and then let's print m.transpose. There we go. And that did not work. Why did that not work? Oh, how about M is equal to? So there you go. So now I can look at this class or this segment, and I can say that clearly jobs have some kind of, there's differences. I can look at your job and know something about you. I can say, well, you're a blue collar person. And if I know nothing else about you, I know you are probably going to crash your car more likely than most people. Probably your kids are more likely to drive the car. You have 1.2 children driving the car as opposed to most people. What else do I know about you? That's about it. I would just say if you're blue collar, you crash your car and your kids drive. Probably your kids are the ones crashing the car. If you were a doctor, I would say you don't crash your car. It doesn't cost me much. Your kids don't drive it. You don't have kids for the most part. You make lots of money. Your house is worth a lot. What's this? The blue book. Your car is expensive. And your car is older, probably because it's a classical car. Who knows? But I can learn something about you that I couldn't learn before. I look at you and I know that you are a doctor because you have a stethoscope on. And instead of me saying you have a stethoscope on, what else can I do? I can say, well, if you've got a stethoscope on, you probably don't crash your car. Now, I can't know that, but I can see one thing and learn something else. I can look at a furry animal and say, I can look at your skin and say you have fur. Probably you are warm-blooded. Probably your babies drink milk. That's the thing. You can learn one thing and then learn something else. So this is a powerful technique for segmenting. Now, we're going to look at clustering in future videos, and clustering is more complex than this. However, just because this is simple does not mean that you shouldn't do it. I mean, sometimes people think that complexity means correct. Simple is extremely useful. So this is something you should use along with clustering. Just for fun, let's change this to something else. Instead of it being jobs, let's look at sex. So let's see if you're male or female, if that is going to affect. See, now we have male and female. And you can see women are slightly more likely to crash their car than men. That's true. Why? Because women are usually driving around on surface streets in traffic, and they are going to crash their car because they're going to get into fender benders. However, take a look at this. If a woman crashes her car, it's going to cost less. Why? Because when they are in a fender bender, it's not a lot of damage. Men tend to drive on the highway more, and when a man drives on the highway, you are less likely to crash your car, but when you do, there's a lot more damage. What else do we know? Let's see. Travel time to work, that's about the same. What else do we want to say? Well, it looks like that male and female, there's not a lot of differences. Maybe having kids at home, I don't know. But that might not be very useful. What about red car? I thought red car was one of my variables. Let's just look at that one real fast. I think red car was a variable. There's a thought that maybe having a red car, you're more likely to crash. So let's just see that real fast. So here we have red car, seems to be about the same for crashing, the same for damage. Ooh, look at this. Kids, if you've got a red car, your kids like to drive it. If you got a red car, you're more likely to have children. Oh, wait, no. If you have a red car, your kids don't drive it. If you have a red car, you make more money. If you have a red car, you're more likely to crash. Well, you know what? Maybe there's something to this. I don't know. But anyways, so this is segmentation. So let's, so what we've looked at here is segmenting data, and we've used the Python programming language for that. And again, I walked through this in a very vanilla fashion. I didn't want to use any sort of crazy Python commands. I try to keep it very high level and something that people who are new to Python could understand it. If you are really skilled in Python, you're probably looking at this thinking, hey, there's a lot of better ways to have done this, and that's fine. But again, this is just getting started off. Now we're going to move into some other things, but this gives you a good foundation for segmentation. So again, if you enjoyed this, hit the like button and subscribe this, and please feel free to reach out to us at DKW Analytics.